How are we doing today? This is Mr. Novak, and for this lesson, you guys are going to be learning about kinetic energy and doing the mathematical application of that. So we've already kind of talked about kinetic and potential yesterday, or this week we've been working on gravitational potential energy and kind of figuring out the equation for that, which was GPE equals mass times gravity times height. And now we're going to find out kind of how to calculate the math for objects that are actually in motion. So our first thing here is kinetic energy is the energy that an object has when it is moving. The kinetic energy of an object depends on its mass and its velocity. The formula for kinetic energy is Ke equals 1/2 times mass times velocity squared, and the unit for kinetic energy is joules. So this is some information that we've kind of already gone over before, and I'm just doing this to kind of refresh. And now what we want to do is we're going to kind of try to apply that mathematically to how can we calculate kinetic energy by solving math problems. Okay. So as we up here, just so as you can see, I have the kinetic energy formula up here, and I have it written in two ways. So it's kinetic energy equals 1/2 times mass times velocity squared, or which is the same thing as 0.5 times mass times velocity squared. So the reason why I have this written is I know sometimes it's tricky to put this into your calculator and kind of remember that 0.5 is the same thing as 1/2, right? They're equal, right? These things are the same thing. Sometimes it's tougher to put that into your calculator, so I'm just putting this up. So this is what you would type in your calculator. Okay, so they mean the same thing. It's just I think this would be an easier way of doing it to help you guys when you're using the calculator to find the problem. So let's read the problem. So an 80-kilogram man is jogging with a speed of 1.5 meters per second. So what is his kinetic energy? So first thing we always want to do is we want to identify the steps in the problem and identify what our variables are. So our first thing, we have 80 kilograms. Okay, that's going to be our mass. So I put 80 kg, I should say. And we also want to find out what our velocity is, right? So our velocity is also the same thing as speed, because velocity is speed in a certain direction. So it's 1.5 meters per second. And then what I want to do now is I'm going to rewrite my formula. So I'm going to use the one with the calculator just to make it easier, right? So I have Ke equals 0.5 times my mass times velocity squared. So then I'm going to plug it in. Ke equals 0.5 times my mass. My mass is 80, and my velocity is 1.5, and I have to square it. So what that tells us, okay, when you do 1.5 squared, that's saying it's 1.5 times 1.5. So that's what you could put in your calculator, or you could just use the square button, which is on your calculator as well. So if I do 1.5 squared, that's going to give me 2.25. I'm just writing it under there so just in case, so you kind of get an idea. So I have 0.5 times 80 times 2.25. Okay, so I multiply all those together. A little bit similar to the one we did with GPE in terms of there's three things we're multiplying, and we're going to get something for what something is kinetic, so what's moving. Okay, so I multiply, put in my little handy dandy calculator, and I get a total of 90 joules. Okay, so it's also just like gravitational potential energy, it's also going to be labeled in joules. So anytime we're dealing with energy, our unit is joules. Okay. Next problem, okay? Let's take a look. So a 6-kilogram object is moving at 24 meters per second. What is its kinetic energy? So let's identify what we're looking for and our variables. So we have our mass is 6 kilograms. Our velocity is 24 meters per second. And we're looking for our kinetic energy. So KE equals 1/2 times our mass times our velocity squared. We plug it in, so it's 1/2, or actually I'll put 0.5 to make it easier because I know I did say that before. So it'd be 0.5. Let me write that up here too. 0.5 times 6, and then times 24 squared. So once again, I can put that in my calculator. I can do the squared button, so I would put 24 squared, or I could also do 24 times 24, and that's going to give me 576. So then I times 6, and then times 0.5. Okay, so I put those in my calculator, and I get a total of, for my kinetic energy, of 1,728 joules. Okay, and that's my answer. Pretty straightforward. So what I would like us to do is to kind of just remember, when you're dealing with kinetic energy, the formula is 0.5, or 1/2 times your mass times your velocity squared. And it's pretty straightforward, and I think we all can get that. So be sure to use this notes to help you kind of complete everything else with your worksheets and go back and forth. And that's really it for math in terms of kinetic energy, and we've already done gravitational potential energy as well. So that's really it, and once again, this is Mr. Novak, and I'm signing off.